Okay, so we're looking at this, and this is also a geometric series, but you might not recognize it, so we'll change it around so that you do. So we got n equals 1 to infinity of 1 over 100 times 3 to the n. This is our c value, this is our r value, and oh, we're starting at 1 though. It's still a geometric series, it doesn't really matter. But here's how I can show you that it doesn't really matter. I'm going to try and work it out. So let's see. The first term would be, when I plug in a 1 there, that would be 3 times 1 over 100. That would be 3 over 100, plus the second term. And I would say, well, the second term is, well, when I plug in 2, right? So that would be 3 squared, that would be 9. In fact, I'm going to write it like this, because I know what's going to happen, because I've done these. So you're not going to be able to figure it out until you do a couple of them, you get comfortable with it. Plus 3 over 100. Actually, let's write it the way I think that you would write it. 9 over 100. And then plus, well, I plug in a 3, because before it's n equals 1, n equals 2, n equals, I'm only going to go up to 3. And what do we have? That would be 27, right? Over 100. And I'm adding them all up. Okay, great. But then I want to start this at 0. Remember? I mean, this is not something that you'll have to do. I'm just trying to show you that this doesn't actually have to be 0, but I'm going to mess around with it so that it is equal to 0, so I can show you. Remember, I want to start with n equals 0, and then n equals 1, and then n equals 2. Maybe I'll go one more. N equals 4. So what is that? Whoops, plus 3 to the 4th is 81 over 100. So now, so that would go to n equals 3. So I'm going to rewrite my summation. I'm starting at n equals 0, and I'm going to infinity. And I know that I want to start at 0. So how can I write this? Well, 3 to the 100, that's like the 100 is there every single time. So that actually doesn't change. I'm going to leave that part in there. I know the 100 is there, so I'm going to write that. And then here I have 3 to the 1, but n equals 0, so I would actually have to have 3 to the n plus 1, right? Because if I plug in a 0, I actually want the exponent to turn out to be 1. If I plug in a 1, I want the exponent to actually turn out to be a 2, so I get 9. So this is actually correct, but now you're thinking, well, there's an n plus 1 there. But I can use my exponent rules and rewrite this as 3 to the n times 3 to the 1. But then that's just the same. This is not work that you're going to have to do every single time. I'm just showing you that it's still, you can mess around with it so that it is n equals 0. And then the 3 to the 1 times the 1, that would be 3 over 100 times 3 to the n. So there we go. C is 3 over 100, and R is 3. And so you're thinking, great, I can use my formula and get that converges to something, something, something. No, you can't. Stop. You can't. You cannot use your formula because R is greater than 1. R is greater than 1. So it doesn't work. In fact, we can actually do the nth term test for divergence, and we could see that it doesn't work. If we let n go to infinity, then it's just 3 to infinity, and it goes on and on and on. It gets bigger and bigger and bigger forever. So this actually diverges because r is, actually the absolute value of r is greater than 1, and we want it to be less than 1. If it was less than 1, then it converges to 0. In fact, all converging series have a sequence that converges to 0. It's not, I mean, the converse of that isn't true. All things that go to 0 converge. It's not necessarily true. But all the ones that do converge, the sequence goes to 0. That might be confusing, so maybe ignore that. We'll just pay attention to the nth term test and whether it's a geometric series or not. But there you go.